Welcome everyone. Good morning, and this is the webinar on what can your Opticline do for you. Right next to me I've got the T3D Opticline. It's got a fully functional touch probe, which is a scanning head as well. So we've got some extras in there to make you think about what you might get from a T3D, but mostly we'll focus on all the things that a standard Opticline can do. Okay, so what I'm going to do is I'm going to talk about live mode, I'm going to talk about the touch probe functionality, and we'll also talk about how it can interface with Prolink, which is like an SPC software. So let's hand over to my assistant Dom, who's going to be doing the rest. Future Dom. Right, I'm going to load the part into the machine now. Okay, and then I'm going to flip into live mode. You can see it's taking the references. And now I'm ready to program. So in live mode, obviously I can add all the features that I want to look at, and it will measure them in real time. So let's say I want to measure the length of the part. Go to general, got my length position there. And it's already going to measure that, if you can hear that noise. Cameras have already moved up. We've got the length there. I know the nominal for that is 215. And the tolerance specification is actually medium. And that's the ISO 2768 medium, already selected for us there, which is 0.5. Let's do a diameter. And we'll just use a general. That's a nominal 30, medium again. Okay, and I've got options obviously to reference my angular reference. I'm going to use 90 degrees here, and I don't have an axis on there, but I could make one. I might make one later. So there's a diameter. You should be fairly familiar with lengths and diameters. Detail contour. Okay, looks really smooth. That's just a very small bit of maybe grease on the surface there. Might be a fingerprint. Okay, so now let's do an angle. So angles are really straightforward. Just draw a box over the angled region. And got a rough on there. Finish that one. Nominal's already right. And also a radius. So you can see it's doing them all in real time. That's an R7.5. Okay, nice and straightforward features. And let's go for some, oh, failed there. Let's go for some features that we might not know. Some of you will be familiar with the thread. We can just select a thread type. We know it's a cylindrical thread, 35 by 1.5. And there we go, and I can choose here which parameters I want. So I can actually measure the flank angles. I could measure a 3-wire diameter, and I can measure a single pitch value. The advantage of the 3-wire diameter can be used to calibrate thread gauges. But I'm not doing that here, so I might put on the flank angles and finish that. Okay. There we go. So it's a good thread from a tolerance point of view. And now I can do things like maybe a run out. So for a radial run out, I need an axis. I know where I want to measure. I can put it here, but I don't have my axis yet, so I'm going to create a new reference. And that new reference is going to be 2 roundness traces. Imagine these like the rollers on one of those old-fashioned run out gauges, one at either end of the part. So I've got my 2 roundnesses. The axis joins the center line of the 2 circular traces. Okay, and it's actually, I've chosen a tactile run out there. I'm going to actually change that to a optical. But this does do tactile run out, which helps with things like overcoming burrs on parts for axial runouts. And that's only on the T3D model. So there we go, we've got a run out there. And let's have a look at cylindricity too. So I want to just check how cylindrical this area is. And maybe a 0.3 tolerance on that. So it's going to do 5 traces and then join them all together in the same coordinate system and get me a view of that cylindricity. Okay, and I can look at that in 3D. So I can tell exactly what distortions we're seeing. It's bent, isn't it? So we can tell exactly what distortions we're seeing. It's very useful on ground parts, for example, to check for trilobing, where a diameter check wouldn't actually tell you that it's out of spec. And that can be extremely useful there. And obviously, if I want to take a diameter from the average of all those roundness traces, I can just go diameter rotation reference, and that'll take the average of all of those. Okay, I can put on the nominal there, so 28. But some other ways of taking lengths and diameters are you can use intersection points or cone points. Lots of different methods here. Now in the realm of the touch probe on the part, so if I need to do an axial run out, but I've got a burr on the end of the part, it'd be very difficult to find that specific part, because if you did it optically, you'd see the burr and it would create a very high result that isn't indicative of the part at all. So what I'm going to do is use the star probe. The reason I'm using the star probe is it's got a much smaller ball, so I know it will definitely fit in this corner. That looks good to me. Okay, so now I'm ready to measure that, but because I've put on a touch probe feature, if you look at the part, we'll measure that in a second. And the touch probe feature can't be measured in live mode, so I have to tell it to measure that feature. So I'm going to right click and measure, and if we have a little close up on the part, then we can watch that measuring. So it's just calibrating the touch probe. That's using a little ceramic ball there. And now it's going to use that side and then gently do that run out trace there. Okay, and that's done. Okay, and we can see some lumps on that surface. So if I go into my detail contour, I can actually magnify that as much as I like. So maybe magnify that 10,000. You can see a little dip there, a little bump there. And obviously this is a huge scale, but we've got exactly what we're looking for there. Okay, and then I can do things like through holes as well. So again, with the touch probe, we can go tactile. We've got options for gear teeth. I don't have a part in there right now that has teeth on it, but I can do that. I can do a bore diameter. I can do a radial touch probe position for obscured features that you can't see with the vision. But what I'm going to do is bore data recording. You can see I'm just going to click here, and I know that's 202. The bore diameter is 5 mm, and I can use the end of the star touch probe just to get a bit more accuracy. Probing depth, I'll go for 5 mm. Now the reference angle I haven't put on yet, so let's just do that. It's just a valley, and it's just on that surface. Let's make that 202 as well. Okay, and then all I have to do is also get the bore diameter from that. So that's like a data recording, and then I can grab the diameter of it. I can go nominal value 5. And then I could also go bore using the length position, and now it'll tell me the center point of that bore as well. So if I grab all these and measure, and we can watch that measuring the bore. Okay, so we can see here the trace that it's done in the detail contour. Let's magnify that a fair bit, and we can see what we're looking at there on the bore. We've got the diameter, we've got the length position, 201.87. So there's some touch probe and optical features that we can do using the T3D. There's a whole lot more we can do though. So for example, we can create PDF reports. We can export to CSV for SPC or data collection purposes, and QDAS. So if I go into there, maybe into my print settings, you can see an example report. And so these are all of the features I've put on, everything there. And these are only the features I've just measured, not everything's on there. And obviously we can populate all this data as we see fit. We also have a results list, and to reorder the results list, we can go into the characteristics list, grab everything we're interested in. Maybe I'm interested in the threads, bring that to the top there, and then when you measure, we'll have everything there, and it will populate in our results list in the order we've chosen. Almost there. Last few things. Okay, that's done. So here's a place that we can add manual data. So we can add profiles, for example, for form testing of parts. And we can import profiles, linear or rotational. We can use those profiles then to check maybe interrupted features or complex features that we've assigned a form tolerance to. We can add classifications, so just a pass, fail, or we can classify passes and fails by order of how good they are, how close they are to the tolerance center. And we can also create variables here for programming purposes. Okay. Welcome back, and welcome to everyone who's joined during the video. I hope you find that quite useful. Obviously, if there are any issues with the quality, we will be sending out a video of this in high quality for you to watch at a later date if there's any detail you wanted to see there. So we've got a few questions while the video ran. I'm always happy to answer questions, so let's get a few of those out of the way now while they're fresh in our minds.
Okay, so the first question was cylindricity that was demonstrated. Does that work with a non-cylindrical surface, i.e. a cam or a square bottle?
Yes, so you can measure a cylindricity on these things, but it obviously will give a sort of dud result. The number that it gives out isn't very useful, but you can still see that 3D aspect of the part. Just remember that this is a polar plot, so it wouldn't give like a 3D scan if that's what you're after.
Okay. Are you able to use the Opticline in order to verify thread gauges?
Yes, so yeah, we've done this in the past. So you can put a thread gauge on, and as long as you've got all of the nominals and tolerances of the actual thread gauge itself, you can then use that to give yourself an accurate result on whether the thread gauges are out of spec. And it's a good little test there. So absolutely.
Okay. Is it possible to measure splines on the Opticline, such as the angle between each spline?
Yes, so you can do the angle between splines. You can check for defects in splines. You can do a run out on splines if they don't have a burr, because you can measure them interrupted. So you can actually get whether that spline is actually concentric as well. The only thing it can't do is obviously the internals of the splines, so the pitch and the minor diameter would be invisible to the machine.
Okay, and we've got, how do these measurement capabilities compare to a CS614?
Okay, so a CS Opticline has a different software. It's kind of a cut down software, so you wouldn't have things like cylindricities. There's a full list somewhere, I'm sure we can find that. So there are a lot of differences between the software and the CS Opticline, but the resolution and the accuracy are almost exactly the same, the only difference being the run out of the axes.
You can purchase an upgrade too.
Yeah, you can buy an upgrade for a CS to get the full software on it. I would just be a bit cautious about the run out accuracy.
Somebody else has just said, can we see the trace of measuring a cam? There seems to be one on the sample on the machine. If not, can we get it sent to us?
So there is a cam on the sample. Let's go through that. Should I do a little demo on a cam? So we've got one here.
Yeah, you could do that and then show the...
So what I'll do the eccentricity of this cam. So we just select eccentricity here. We could go onto the screen. Yeah, general eccentricity and measure that. I know it's about 3. Just going to finish that. So what I'm going to do is I'm going to turn off our touch probe characteristics. And then I can go into live mode here. So let's see what it measures. So this is just an eccentricity. Obviously we can do a trace as well. But usually you need the actual profile of the cam. So different types of cams have different profiles and you need to upload that into the machine beforehand. So eccentricity, yes. Lift, yes. And the angle, yes. Those are usually the main things. And then a profile, if you, there is a separate license for the machine that you need to buy just to do cam profiles. We've got it on this one, but I don't think it's worth going into that right now. Okay, next. Is that all the questions?
We're going to come back to Amber at the end, who's asked us to demonstrate how to program to run a spline, so we'll do that at the end.
Sure. Yeah, I don't have any splines on the part, so I'll try to make something up. Yeah. So that's that. We can move on to the cobot now. So we've got a little video of our cobot in action. Hopefully you find that informative. Perfect. So this is a robot loading of an Opticline, completely automated. Once you've got palletized parts, you can set it up to automatically take every part in a pallet, load it onto the Opticline, take the data out of the machine after it's done. And because of the fast run times, the robot's almost always moving. And once you've got all that data, you can then view it in SPC. So what we are aiming for is lights off production. So we can have a robot loading a machine, the SPC goes straight back to the machine tool, warnings and etc. can all be developed there and show how the tool's drifting, for example, and then use that to create a fully automated solution. Okay, so now I'm going to go on to Prolink, which is what the Opticline works really well with. This is the part where we use the data that we collect. So every time we measure a part, we get a bit more data, and every time we get that, we can look at the. So if you want to look at the screen, we can show what the data looks like. So here's some I did earlier. So you can see these are graphs of all of the features. Now obviously this is the same part, so I did mess around with the thread here, but other than that, nothing's changed because it's very repeatable. So really this is sort of the brains of the operation. The Opticline is a very clever machine on its own, but once you interface it with SPC and data collection, you can start to do truly wonderful things. You can look at drift in tooling, you can set warning limits, you can set notes to operators, you can set it up to view into factories. So if you've got multiple factories, you can actually get a dashboard. And then that dashboard shows everything that's going on all of your Opticlines and all of the features, and as soon as a failure comes up, we can ping that and it will pop up on the dashboard as something to look into. So I don't have a dashboard set up right now, but the idea is this is the result for one part, and then at the top level of the dashboard, which is in the Prolink software, which I'm sure we'll get to on a different webinar, we'll have more sort of options there of exactly how you can take all that data and then start using it at a macro level over the factories or inside one factory over multiple machines. Okay.
Okay, we've got a couple more questions. So we've got.
Excellent.
Let's go to the first one, which was, please can you demonstrate how to set up the program to run a spline?
Okay, so I'll show how you do the measurement on this part, and there isn't a spline on here, obviously, but if we assume that there is, I can set up a feature as if it's measuring the spline. So to start with, what I could do is find an angle position, and then I go valley, and then place it on where I think the spline is. And that will find the valley between two splines, which is much more repeatable than one spline itself, or one of the peaks. So I've used that, and then I could right-click and duplicate it. So now I've got two angle positions in the same place. So one of them is like a reference position. The next one I can set to nominal value related. And then the nominal value would be the nominal angle between the splines. So if it's, say, 22 splines, I could go something like nominal value is 360 divided by 22, which is 16.36. So I can get it to do the maths for me there. So I can say, right, the nominal value is this, let's check what it is. Obviously measuring that wouldn't give much of a result because there isn't any splines on there. But that's the angle between the splines, and then we could do something like run out, radial run out, and you see you've got options up here for interrupted. So I can put an interrupted radial run out there. And then we can tell it whether they're regular interruptions or whatever they are. I'm just finding that. One sec. I can use a general. Extract the values. I can't see the regular interruptions.
So, Dom, I just let Amber know that we'll give her a more detailed demo afterwards.
Yeah, that's absolutely fine.
One more at the moment, which is, can we see the visual cam trace?
Yes, so with the eccentricity here, that's the visual cam trace. So that's my detail contour. That's it after filtering, so that's centered the cam now. So it is a very circular cam, unfiltered. Obviously you've got the eccentricity there. And you can see the position that it's measuring in. It's fairly simple. If I was to do something like a roundness as well, we could also have a look at that. Let's just measure it. Okay, so it's a very round cam. There's my detail contour, and I can set my magnification up a bit, really see what's going on there. Okay, so there's a bit more detail on the cam trace, showing exactly what the surface looks like, but it's a really good surface. We're talking roundness of 2 microns, pretty good. Okay. Has anyone got any more questions? So that's kind of most of what we've covered.
So we've just had one come in. What are the main differences between the TO3 and Lara software?
Right, well, my favourite difference is live mode. Live mode here is so useful. Honestly, it saves me hours of programming every time I need to do a part. Instead of having to remeasure every feature as I go, live mode, when it's on, you just put a feature on there and it's already measured by the time you've set up your nominals and tolerances. It's honestly the best bit about it for me. There are loads of other differences though. The menus and user interfaces, and it's got lots more features that you can actually measure. So there's a load more in there. If there's anything specific that you use your Opticline for, that you want to know if Lara would be a good upgrade for you, I'm sure we can get an answer to that as well. Yeah, so anyone got any more questions?
Is the Lara software compatible with our existing CA618?
So any TO3 Opticline can be upgraded to Tolaris. So yes, I believe so. All right. So thanks everyone for joining.